Within the same dialogues, Galileo also argued that light need not be instantaneous, but may actually have a finite velocity. But the closest Galileo could get to that velocity was that light had to travel at least 10 times faster than that of sound. However, research in astronomy, light, and natural philosophy were once again interrupted by the actions of the Church. The natural philosopher René Descartes had written in 1629 through to 1633 about the nature of the ether and the solar system. However, it would not be published out of fear of the Church, and that what they had done to Galileo might be done to him. Descartes decided instead to rewrite this work by softening the heliocentric views. This softened version was compiled into a textbook called Principia Philosophiae, which Descartes wanted to have replace the Aristotelian textbooks which were taught at the universities at that time. The original copy eventually was published in 1664 in the book Treatise on the World and Light, or otherwise called The World. In Book 3 of Principia Philosophiae, under the title of The Observable Universe, Descartes states, "The only difference between my position and those of Copernicus and Tycho is that I don't attribute any motion to the earth." Descartes made a few arguments to demonstrate his case. The first being that the fixed stars are just like our sun, and are not fixed to the outer crystal spheres, but rather are the centers of their own planetary systems. Descartes states that each of these systems is filled with a fluid, openly dismissing the idea that the heavens are empty, and the motion of these fluids drag the bodies like planets in it. And the fluid eddies of the planetary system have smaller eddies, which explain the orbits of the moon around the earth and the orbits of the followers of Jupiter, which were discovered by Galileo. Descartes expresses in this book the principle that Newton later takes as his own, and much later becomes known as Newton's first law of motion. Descartes expressed this first law in 1644 by stating that people tend to believe that motion requires actions, and therefore an object in motion requires an external force to continue said motion. But Descartes shows that that belief is caused by our atomized experience of life on a planet with gravity, and that the opposite is actually true, that it takes effort to prevent the body from moving down, including your arms, that the motion is ever present and we apply effort to stop ourselves from collapsing, and that we require effort to continue motion because of friction and gravity, otherwise we would remain in motion. Descartes saw this motion as intrinsic to the functioning of reality, and assumed that each natural element intrinsically moved at different speeds, such that fire element particles were intrinsically fast, and their quickness tore holes in slower objects which we see as burning or disintegrating. Air, earth, and water were naturally slower elements. Descartes held that the earth was trapped in this fluid and was itself at rest. The quick motion of the ether traps the atmosphere to the earth, and the motion of the air trapped the rocks to the ground, as rock is intrinsically stiller motion, and all is carried by the heavenly fluids. Quoting Descartes, "Let us assume that the earth is at rest, having no innate tendency to motion, because we don't see any such propensity. But let's not think that this prevents the earth from being carried along by the currents of the heaven, following the motion of the heaven without itself moving. Compare this with an unanchored ship that isn't driven by the wind or oars, floating motionlessly in the middle of the ocean, though it may be imperceptibly carried along by the ebbs and flows of the great mass of water. In this strict sense, the earth is not moving, nor are the other planets. because they are not transferred from the vicinity of those parts of the heaven which they are in immediate contact, insofar as these parts are considered as being at rest. Part 3. What the heck is light and ether, anyway? 4 years before the publication of Descartes' The World, the renowned natural philosopher and father of chemistry, Robert Boyle, was conducting experiments with a vacuum chamber and air pump which he invented. Boyle used his air pump to remove air from his vacuum chamber, to which he had placed a bell which could be struck inside the chamber. Boyle discovered that it was the air that allowed for the sound of the bell, as when the air was removed from the chamber, the striking of the bell would not produce a sound. The air can be removed from the chamber, which prevents the bell sound from having a medium to travel through. Therefore, sound requires a medium of air to exist. However, air was not clearly needed for light to travel. As the chamber was made of glass, and the bell was visible inside the chamber after the air was removed. Boyle concluded that light travels through a medium made of particles so much smaller than air that they can penetrate through the glass, unlike air, and therefore cannot be vacuumed out by his air pump. Boyle also experimented with magnetism with his vacuum chamber, placing a compass needle inside, and after evacuating the air from the chamber, a magnet was moved around the glass jar which caused the compass needle to move. Therefore, light and magnetism, whatever they may be, can travel through solids like glass, but air cannot. So light and magnetism must be smaller than air. In 1665, Dr. Robert Hooke of the Royal Society and student of Robert Boyle published his book Micrographia, which mostly contains observations he made with his invention, the microscope. The book also contains some natural philosophical explanations of what the ether and light may be. Hooke considered light to be of an exceedingly quick but very small vibrative motion, possibly having the vibration perpendicular to the direction of propagation. Hooke's ether was similar to Descartes' in a few ways, and differed drastically in many other ways. Hooke thought if light was leaving stars in particular form, then stars would have to get smaller over time, as the amount of light particles leaving the stars would leave the star with no more fire element particles after a brief period of time. Hooke, being the man that gave us the spring equation, believed that light had to travel through the universe like a bunch of springs attached to each other, such that a motion of light physically traveled through the universe, but the restoring force of the spring would return energy to the source, and therefore would not deplete the stars. Descartes' ether had sent energy through the little stuff, like energy is transferred through tightly aligned billiard balls, such that no object moved, but rather that light energy would just be the tendency to motion, whereas Hooke held that light itself was in motion. Hooke, being the student of Robert Boyle and main assistant to Boyle's experiment, had learned that sound is propagated by the medium of air, and so, like sound, light traveled in straight lines propagated in all directions with longitudinal spring-like motion, an idea that will be picked up by Christian Huygens some 30 years later, when Huygens describes light spreading in all directions in a series of waves in what he calls the luminiferous ether. Descartes provided an explanation of how the planets are forced to move in the direction of the ether vortex, as he believed that the ether, heavens, was composed of fluid matter, which was in motion. Boyle provided an explanation that the ether was composed of matter, that must be very small as to penetrate all things, and Hooke provided explanations as to how he believed light was traveling through that ether. In 1676, Ole Romer provided an observation about the velocity of light, such that it was possible for him to predict a planetary event to the minute. Romer was observing the Galilean moons of Jupiter, and discovered that the moon Io had a constant, predictable orbit around Jupiter when watching it throughout the week or month. However, Romer found that when observing that constant velocity over the period of a year, the time it would take to arrive would shift back and forth between too early and too late. Romer realized that since Earth and Jupiter are in different elliptical orbits around the Sun, there would be points when Jupiter and Earth are as far apart as they can get. And there will be times when Jupiter and Earth are at their closest. The further away Jupiter was from the Earth, the longer it would take light reflecting off Io to reach Earth. And the closer Jupiter was to Earth, the quicker light would take to reach Earth. Romer found that light traveled at a velocity equal to about 22 minutes to span Earth's diameter, or about 220,000 kilometers per second, or about 136,701.66 miles per second. This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.